Okay, we're back. Okay, so the next part is we're looking at the transformations with coefficient of 1 for the root function. The root function is as follows. So this is the answer to all of this with the root function and how it was applied. Let's go back to the beginning and describe what happened. So, back to the beginning, we're looking at the root function is applied the following transformations. This transformation table stayed the same. Whether it was the root or any other function, this transformation part up here, the mapping notation, I guess you would call, it stays the same. What changes is the basic coordinates. So we're looking at the basic coordinates of the root function as follows. And very important to note that at 0, 0, there is a solid dot at 0, 0. So you would have a solid dot right here. So, when you apply the transformations, we'll quickly find out that if I take the 1/3, some of these values will not be nice. So, we need to find nice points. So I'm going to change the ones that give us not nice points and make them into nice points. And we get 9, 3, 36, 6, 81, 9, and finally 144, 12. That's because all of these numbers, we need to have numbers that are divisible by 3. So, and the only way we could do that is note that these numbers are multiples of 3, and therefore the squared values of those values are these values here. So, they convert to the following coordinates. Once we note this, what we can do then is describe the domain and range. Let's go look at that again. Domain and range of a root function is as follows. X belongs to real such that x is greater than or equal to 0. In our case, the graph is moving. X belongs to real such that x is greater than or equal to -1. So if we write that in set interval notation, it will be x belongs to square bracket -1 all the way up to infinity. Now, there was a vertical reflection, therefore the range changed. The range, which would normally go from 0 to infinity, reflected. And then it also translated. So, y belongs to real such that y is greater than or equal to 0 normally changes itself to y is less than or equal to 1. And that's because there was a vertical translation of 1, so then therefore we're going to look at it and a reflection, and therefore it is less than or equal to 1. Next part. Those are the two parts that are changed, so I unhighlighted them from the original so that you can remember that. This function is normally increasing, that's normally, but because there's a reflection, it changes from increasing to decreasing, and it's decreasing on the interval from -1 to infinity. Alright, next part is as x approaches 0, the y approaches 0 normally. As x approaches infinity, positive infinity, y approaches positive infinity normally in a root function. How does that change? Well, as x approaches 0 from the positive side, folks, because remember, it's the positive side we're looking at, and that's very important to note when we're looking at this. So again, it's x approaches 0 from the positive side, y's approach 0 from the positive side. This changes itself to be as follows. Here we go. We change the 0. Now it's approaching -1. From what side now? What side will it approach from? It is approaching -1 from the positive side still because there was no horizontal reflection. The reflection was only vertically. So, what are we looking at here? Well, it approaches 1 from the positive side, and the y values also approaches 1 from the positive side. So that would be this one right here, 1 from the positive side, negative 1 from the positive side, means from the upper part. So the upper part, it's approaching negative 1. As x approaches negative 1 from the, x approaches negative 1 from the right side, and this is approaches 1 from the positive side. So it approaches 1 from the positive side. Well, because there was a reflection, it's actually not going to be from the positive side, but from the negative side. So approaches 1 from the negative side. And then again, as x approaches here from the positive infinity, y approaches negative infinity. Again, when we're sketching it, so imagine you're sketching this particular graph, you're going to look at it in such a way. So let me do a quick sketch to show you. The graph is going to look, it's going to have a reflection and a translation so that the graph will look something along the lines of it moved to the right one and up one. So imagine you're looking at a graph that looks like the following. Looks something like this. And so when we're looking at describing it, you know that the endpoint approaches, x approaches negative 1. So okay, move left 1. So let's move it over here. And it's looking something like that. So it approaches negative 1 from the right side. It will approach 1 from the negative side, so the underneath. X approaches infinity, well, y also will approach negative infinity because it's getting larger and larger in a negative direction. And the last part is the equation. This particular equation right here is the equation with replacing the f with a root sign instead. So this f here just gets replaced with a big giant root sign. All right, last one. What about the function for the exponential function? So for the exponential, we use the exponential coordinates. Here we go. And this one is not going to be as easy, meaning that we want to pick values that will be nice for the x, but they won't necessarily be nice for the y. So we're picking these values, and these values result in the following. So again, we're picking nice x values to be able to plot them. And don't forget the asymptote. There it is, folks. And these are all the different changes that happen, whether it increases or decreases as follows, you'll see. And then we have the original and then the changes. We highlighted the changes in red so that you can note them. And then finally, a simplified version of the equation. The reason this got simplified this way is important to know that because these have the same base, we can multiply them together and add that base. So when we expand this, it would be 3x plus 3. Because I add another 2, it'll be 3x plus 4. Okay? Something to think about. If you have any questions, please ask. That's the end of this video. Take care.